Okay, in this video, we will be learning how to find the least common multiple, or we could call it the LCM. But first we have to understand what the least common multiple is, or the LCM. What is it? It is the smallest number that two other numbers can fit into evenly. That's without a remainder. Okay? Evenly. All right, so an example would be, what is the least common multiple of 3 and 4? Okay, so you could count by 3s and 4s. You could say 3, 6, 9, 12, 15, and you can go so on. Well, we're going to stop there. And then you can say 4, 8, 12. All right, so I have the same number, 12 and 12. The least common multiple of 4 and 3 is 12. That is the least common multiple of 4 and 3. Okay? Now, it's not always that simple. You could count like that. You'd be counting forever for a lot of times. But there's another way to do it, and it has to do with a couple different steps. And we're going to learn those different steps. Okay, so now let's talk about the steps, and we're going to do an example to learn it. So I'm going to write find the least common multiple of, let's say 12 and 16. Okay, so step number 1 is to factor out the numbers. Okay, so the numbers are 12 and 16, so I'm going to write 12 and 16. Now I'm going to factor these out, and I'm going to say 12 can be broken down into what? What multiplied by what equals 12? 3, I'm going to say 3 and 4. 6 and 2 would also work, okay? And then 4 can be broken down into 2 and 2 again. See how nice and neat this factor tree is? I can clearly see that 3 and 4 make 12. 2 and 2 make 4. Okay? Very clear, very neat. All right? It's important that we stay neat, or else we will confuse ourselves later. Okay? 16 can be broken down into what? I'm going to say 4 and 4. 8 and 2 would also work. Okay? Now, 4 can be broken down to 2 and 2. This 4 can be broken down into 2 and 2. Okay? So I have 6 numbers down here. I'm sorry, 5 numbers. So 16 is 2, 2, 2, and 2. Okay? And 12 is 2, 2, and 3. So step 2 is to make multiplication problems. Okay, so what I'm going to do is I'm going to take this 12 like this. I'm going to write 12, and I'm going to write 16. Okay, I'm going to say 12 equals, what does 12 equal? A 2, and a 3. We always go smallest to biggest. Okay, smallest to biggest. Okay, so I'm going to say 2 times 2 times 3 equals 12, because those are the factors of 12 that we end up with. Okay, 2 times 2 times 2 times 2 equals 16. So I'm going to write that down here. 2 times 2 times 2 times 2, all right, equals 16. All right, now, when we have repeating numbers like this, we can smash them together to be one number. Okay, so there are 2 2's right here. So we can say 2 multiplied by 2, or we can say 2 squared. There are two 2's being multiplied together, or multiplied together. I'm sorry, that was bad grammar. Multiplied together. So I just smashed those 2's together, and I said 2 multiplied by itself twice, or 2 squared times 3. Okay? All right, now I've got 4 2's down here, and I'm going to smash them down into just one single 2. All right, so I'm going to write a 2, but I have 1, 2, 3, 4 2's, so I'm going to write a 4 right there. So I've got 2 to the power of 2 multiplied by 3 here, and I have 2 to the power of 4 here. Okay, 16 equals 16 equals 2 multiplied by itself 4 times. 2 times 2 times 2 times 2 equals 16. Okay, now on to step number 3, and I'm going to write it up here. Okay, 3 is put the highest powers of each number into a new multiplication problem. Okay, what does this mean? The highest power. Okay, the highest power is this number right here. 4 to the power, or 2 to the power of 4 and 2 to the power of 2. Which one's higher? Well, 2 to the power of 4, because 4 is bigger than 2. Okay, so I'm going to create a new multiplication problem, and I'm going to say, take the highest power of each number. Now, we're going to ignore these numbers, and we're going to look at these numbers, okay? What numbers are we working with? 2's and 3's, okay? So we have 2 to the power of 1, 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 and 3 to the power of 1. And over here we have 2 to the power of 2, 3 to the power of 1, and 2 to the power of 4. So we're going from smallest number to biggest number. Okay, so 2 would be the smallest number with the highest power of 4. So I'm going to write that here, 2 to the power of 4. Okay, so now we're done with the 2's. All the 2's, we can ignore the 2's now. So now we're just left with a 3 times 3 to the power of 1. Okay, and this is going to equal the LCM. All right, so what is 2 times 2 times 2 times 2? Or 4 to the power of 2. Okay, 4 to the power, or 2 to the power of 4, 2 to the power of 4 is, we can look back here and we could say, oh, that's 16. 16 times 3 equals the LCM. Now, if we have to stack these and multiply them, let's do it. So let's move that down here. Let's say 3. 6 times 3 is what? 18. 3 times 1 plus 1 is 4. So 48 equals the LCM. All right? This, with everything stated out like this, everything written out like this, is the least common multiple process. This is how you find the least common multiple. Okay, let's do one more example together. Okay, we're ready for the second example, and I've written the steps up here for you to remember. Now we're going to find the LCM. We're going to find the LCM of 15 and 12. Okay? We're going to find the LCM of 15 and 12. Now we're going to factor the LCM of 15 and 12 out. So let's start with 15, and let's say 15 can be broken down into 3 and 5, and 12 can be broken down into 2 and 6, but 6 can be broken down into 2 and 3. Again, look how neat the factor trees are. I can distinctly see and clearly see that the 3 and the 2 make the 6, and the 6 and the 2 make the 12, and the 3 and the 5 make the 15. So this is step 1. It's done. I'm done with step 1. Let's move on to step 2. I'm going to make the multiplication problem, so I'm going to write the 15 and the 12 out like this, okay? And I'm going to say that 15 is 3 times 5, and 12 is, we're going from smallest to biggest, 2 times 2 times 3. 2 times 2 times 3. Okay, now I see some repeating numbers here, so I can smash those together, and I can say 2 to the what? There's only two 2's being multiplied together, so I can say 2 to the second power multiplied by the 3. So the 12 is 2 times 2 times 3, and we can smash that together. 2 to the, there are two 2's being multiplied, so 2 second power multiplied by 3. Now, we're done with step number 2. Let's move on to step number 3. So we're going to put the highest powers of each number into a new multiplication problem and solve. So we're going to say that the LCM equals the highest power that we're working with. Let's forget these numbers right here. And let's say that we're working with 2's, 3's, and a 5. Okay, so what's the highest power of the 2's? Right here, 2 to the second power. Okay, so now we can forget the 2's. So what's the highest power of 3's? Well, both 3's that we see are 3 to the first power. So we're just going to say 3, just a regular 3, and we have a 5 that is to the first power. So we can just write a 5. So 2 to the second power times 3 times 5 is the LCM. And that's going to equal what? 4 times 3 times 5. And what does that equal? 4 times 3 is 12 times 5, which the LCM then equals 60. All right? That, again, is a whole problem. This is what we would like to see whenever the problem is complete. If you need help again, please rewind and watch the video. And if you need help again, we will talk about it in class. See you in class.